Hey. Technology, we love it. Right, so anyway, like I said, I'm talking about a library called measurit. It's on Read the Docs, or you can go here, it's the homepage. My name's Fein. I have a couple Twitter accounts. My technical stuff's at PeepCode, most about Python. It's probably my main language for the last decade or so. I'm a freelancer. There's a couple of us here. I'll talk a little more about that and kind of the relationship to this code base towards the end there. So why do we care about measuring things as programmers, right? Like, why don't we just write code and just let it go? And so I think basically, if you don't have real data, where's my image? Yeah, you're basically just throwing darts, right? If you're not gathering like actual metrics and information out of what your program is doing, like you have no idea where to optimize. You have no idea why you're spending like $1,000 a month on Amazon Web Services and so forth. And so this library came out of a desire to kind of provide some better tools to sort of try to help answer those questions. And so measurit provides tools for like two different kinds of tasks, like one of which I called like metrics. So these are like your runtime production numbers. Like the sort of stuff you would get at a New Relic or other sort of monitoring services. But it can also be used for benchmarks. And so that's the sort of thing where you have an isolated piece of code and you just want to see how fast can I make this algorithm go, or like how fast does it run on this piece of hardware. And so those are similar but kind of fundamentally different things, and measurit can be used for both of them. Okay. And so the main questions we tend to ask around here on these topics are, how many and how long? So how many bytes did it take? How many rows did I read out of my database? How many web requests did I make? How many web server hits did I get? And then how long did those things take, basically in terms of wall time? And so why this library? You know, it's a bit younger. I think it's pretty cool. The two main reasons I like about this is it allows you to measure all, basically, and I'll show this later, like all the different ways you can execute code in Python. And there's a handful of them. And this actually covers all of them in one integrated place, while maintaining kind of like a decoupling between the instrumentation and the output. And so that you can like instrument your code with this kind of metric stuff and then have it at runtime like either just print to the screen or save your data to a CSV file or stuff like that. And so those are like the kind of two strengths I think that are going here. And so this kind of leads us to sort of the next, what I hope would be an obvious question, is like, how is this different from something like New Relic or BitDeli? Measurit is intended to be a lot more generic and a lot lower level. Like New Relic is basically like you drop in like 6 lines of code in your code base and pay them how many, or $100 a month, and it just automatically does everything for you, which is cool, but it's limited to a particular set of frameworks and is really, really very much focused on the web. And like we heard before, we're using Python for all sorts of different things. And measurit allows you to kind of instrument stuff that maybe New Relic doesn't support yet. Okay. And so just like I said, this project actually came out of some freelance work I did where I wound up actually just so like, wow, this is cool, and I'm not going to charge my customer for it because I wanted to share it out with the world. Yeah. So the name measurit actually comes from measuring iterators. And so we haven't done this here in a really long time. Let's play the hand game. Everybody put your hands up. Come on. Okay. If you don't know what an iterator is in Python, put your hand down. Great. Okay, how about generators? Yield keyword? Wow, awesome. I'm going to skip this whole section. Makes life really easy. All right, so we can skip that and go straight to demos. Like, let's just go look at some code. Okay. And I actually have a tool that I like to use called Player Piano for like faking this, but because this is time sensitive, that wouldn't work. So you're going to have to bear with me as I like type my stuff in here a little bit. Most of the examples just for kind of this like first section of stuff where I'm just like showing you the basic libraries. I'm just going to use some really contrived examples. instead of real world stuff. So like obviously you're not going to sleep in your code. Let's say we have some function that does some math, and math, everybody knows math is hard. Yeah. All right. So this is just going to be a really simple function that's just going to return a list of squares. So, because math is hard, it's going to sleep for a little bit. People familiar with this yield keyword? Yeah, we're good? Okay, cool. So this thing is actually a generator, right? So, right, this is not a regular function call. Like we get this thing back that we can iterate over. And so, sorry. Measure it lets you wrap these things, like wrap iterators, and then iterate as you iterate over them, pull out timing and count information just transparently. Underlying. Oh, sure. Underscore in the interactive shell, underscore just is the last value that's returned. So if you're lazy or you forgot to save your variable, you can kind of just pull that. Okay. Yeah. N? That's a. Ooh, that's a really nasty typo. Sorry. Thank you. Please continue to do that. Also, because people always ask, this is a shell called bpython. It's like the IPython I always wanted. Okay, that's going to be a lot better. So it equals math is hard. Right. So we can make a wrapped version of this thing. All right, and then we turn it into a list. Measure it, well basically, so we get that list object back totally transparently, but kind of as a side effect, the library goes out and counts how many elements we saw and how long they took in total to consume it. All right? That makes sense? Cool. And so it actually turns out there's a couple of different variants you can do on this sort of thing, besides just sort of how long does it take to consume an entire iterator. You could do just like how long does the first one take? Right, so that's actually going to run through all of them, but only give you the timing on the first one. And so we'll see some examples later where this can be kind of particularly useful. And also I've got a variant that allows you to do basically counts for each item. All right, pretty straightforward. And I'll show you how this works all behind the scenes. But basically, like, this saves you from having to write all this code to do this yourself. This is actually, once you get into the thick of it, it's kind of non-trivial. You can also pass these things a name if you're so inclined. We'll call that one Fred, because why not? All right, and so you get a little nicer output. And that name can then actually be used in sort of the other outputs so that you can actually figure out like what part of your code you're actually instrumenting here. Cool so far? Great. There's a whole bunch of, like I said, variants for these, for like all the different ways you can write Python code. And so these are just, the variants I just showed you, like work just on arbitrary random iterators. If you've got a decorator function, or rather, yeah, that's returning a generator, you can also decorate it. All right, so this is just a little nicer way of expressing this. No. Okay. And so now, basically, anytime you call this function slow, right? It's gonna record these metrics, which is really handy. The library also has enough smarts to be able to figure out a good name for the thing. So basically, it infers from the function name that the metric you're trying to record is called slug. Cool. There's also support for like what I call reducer functions. So this is the kind of function that takes, rather than outputting an iterable, takes an iterable and consumes it. So you could think of these as like aggregator functions or like a batch save where you pass like 50 rows to your database and you want to know how long it takes to save them, stuff like that. Sorry. All right, so we're going to pass some iterable in. Right, pretty straightforward, right? Pass a range of objects in, and then it kind of, we're getting back, rather than a list, we're getting back as kind of a single item, and so we measure how long it takes to consume. There's also another variant, which I'm not going to bother to show here, that I call measure produce, which is where if your function returns something that's, rather than being an iterable, is like a list with a known length, you can actually save a lot of time by just popping the length right off. And so there's a variant for that as well. Cool. All right, let's look at some more practical examples, right? Because this is all just kind of demo code. All right. Oops. So, like one of the places you can use this. So, do people know that files, like open files, are iterable? If you iterate over a file, you just get lines at a time. And so this, right? Like you can just drop this in really naturally, kind of into existing code bases and kind of just instrument it without doing a lot of work. And so this is just a word, like standard English words list. No, it's closed. It's cut off. Yeah. Our high quality screen here. So this thing, right, just can directly wrap this file handle. Sorry. This mouse a little. All right, you can do some like silly little tests. All right, and so it rips through and it says, oh, hey, we've got 99,000 lines and this takes 0.5 of a second. All right, so hopefully people can see kind of where this sort of thing would be useful. All right, where else? Databases, the Python DB API. So like a lot of people are probably familiar with the Django ORM or SQL Alchemy, stuff like that. There's a much lower level standard called the DB API, which like is how you directly interact with an SQL database in Python. And so cursors for databases are iterable too. And so we can use those things there as well. I'm just going to copy and paste a little bit of this here. All right, so basically this words DB has just got a really simple table with actually the same word list data. We can do stuff like I think this is probably the first time I've written like SQL by hand in like years. Years, it's crazy. Oh. Yeah. Why? What? Oh, yeah, thank you. Okay. And and we're just going to throw these away. But again, right, like kind of see this just transparently on top of these existing queries that you might already have sitting around. You can just wrap this and basically use your code and kind of get these metrics to come spit out of it. You can kind of do a similar thing, you know, for the, you know. And so, like, say your database, you know, certain operations, like, take more, like, it takes a long time to figure out the result set, and so that first result takes a while, but then, like, the rest of them are really fast. And so this is the kind of instance where, like, something like a measure first would be useful. Right, so that's just, right, and then, you know, it's SQLite, and so it takes, like, no time at all. But, right, it just gives us that first element, and continues to actually loop through the whole thing. Some more stuff. Botto, which is the binding for Amazon Web Services, works with this pretty nice too. Oh, give me one sec. I have to get online to actually make this work. Sorry, I forgot about this part in the rush. Me? No, I just need to load my Amazon keys, which are conveniently encrypted on this flash drive. No. Okay. Okay, cool. Sorry about that. That's interesting. Sorry about this. Let's try that again. Ah, cool. There we go. All right, so we'll go grab some random bucket. This is just one of my buckets. It's got a whole bunch of data in it, which is great. All right, and so let's say we just want to list the keys on this thing. So there's about 5,000 plus keys that match this prefix in this bucket. Depending on how fast the network is here, this will take a couple of seconds. All right, cool. And so it pulls down all of those in, you know, 3.5 seconds. Now, what's cool about some of the different versions of these things is that it actually can give you some insight into what the heck's going on in some of these libraries. So the total thing takes 3.5 seconds, and the first one takes, you know, 1 3/4 seconds. All right. Like, you don't have to go, like, so obviously there's some batching or pagination or whatever the heck's going on in the library underneath. You don't actually have to go look in there to that. So this kind of gives you insight into kind of how your program is behaving a little more. Yeah. Okay, let's see. What else? All right. So, like I said, demos, right? So all these kind of different variants, the decorator versions, files, DB API, S3. Like I said, we can do a lot fancier things with output besides just printing it to the screen like we have been. One of those is tables. I'm just actually going to run this. I'll show you this code, but so basically, this code is just going to generate a whole bunch of random loops through a kind of similar sleeping function. I'm not going to actually run this real time because to actually get enough data to give you meaningful results, we'd be sitting here for 5 minutes again, which would be boring for everyone. So just don't pay attention to manual having the cursor. But basically, right, we're just looping through kind of a bunch of different random amounts. And what this table thing does is basically, as it runs, records all these metrics, and then at exit time, calculates like your average for each metric and the standard deviation, both of the count and the time. And so like you've already got like great like runtime statistics, like really easy, right? So this is really handy for something like benchmarking particulars, right? You can just write your code and like run it as hard as you can and then kind of see what kicks out. The other thing we can do with this is graphs. Everybody likes graphs, particularly when they're going up and to the right. And there's a very, let's plot demo. Yeah, Chicago's crime rate. So again, very similar, like we've got a loop and we're just going to slam it through some random data. And so this doesn't look like it did much, but isn't big. It will, for each metric it encounters, generate a graph like this using matplotlib, which gives you a nice histogram of like all the metrics you got, of all the data points you got, both for count and time, and then actually plots them against each other. And so this is an n squared, a pretty typical n squared function. You can actually see that coming out in the curve. And so like you can understand the runtime of your behavior of your program like really easily, right? Like you don't even have to know what big O notation means to understand that like time versus seconds, right? And so this just automatically spits these things out for you, which is pretty cool. Okay, let's see what I got next here. You know, other current outputs are CSV files. Like we'll just dump the data straight, you know, each line by line for every point it records, and then statd. People know statd. It's basically a run for production metrics gathering. It's pretty popular kind of standalone server for kind of gathering and graphing these things. Like it's often like when you go into people's offices and like they have all these charts of their business stuff for like how many web hits they get. That's almost always statd. And so it also integrates with that as well, so that you can kind of just hook it into your existing production stuff. All right, let's flip to that. Like I said, I'll just show you this for completeness. We can actually do all the different ways that Python can execute code, and we've actually covered most of them. And there's really only two left. So just. And this is really as much for just completeness as anything. I was just like, once I'd written all the stuff for iterators, I was like, well, I might as well just throw these in here too. Some other slow function. Got that. So obviously this function would preferably do something. Return slow. So when we call that, all right, every time we call that, we'll get a metric for it. And the last thing is if you just have arbitrary blocks, there's a context manager to support those. So give it a name, Bill this time. You can also pass an account, and so this could be, say, the size of the file you're working with in this block. Kind of whatever particular count number is relevant here, and if not, it'll just kind of throw in some useless value. All right, it doesn't really matter. All right, and then records a metric. So that's really all the different ways you can run code in Python. That's it. That's it. We covered them all. And there's no other library I know that kind of allows you to do that kind of instrumentation so broadly. Cool. Yeah. Block. Like I said, all the different ways you can measure your snake. Cool. All right. So do people want to see what this looks like on the inside? Yes. OK, cool. All right. Let's take a look at. So just pull this up on. Where are my repos? Okay. All right. Is this readable? Yeah. So you'll look. If you look at this file, there's a comment at the top that says you're not expected to understand this. That's why it has tests. That includes me. I sat down, I wrote this in a fury of hacking in 2 weeks, and when we get into this, there is no way I could maintain this thing without full test coverage. Some of this stuff gets completely insane. All right, let's skip over this. So this is this basic measure iterator, right? So it takes an iterable. Yeah, right. It takes the iterable, and then really we're just going to keep track of time. So this is this kind of clever trick we're doing, so that rather than having the enumerate function basically takes an iterable and returns two things, an integer count, like the loop index, and then the underlying item. And so we can actually use that as a trick to quickly get the total count. Rather than having to increment items one by one, we can kind of just let it do that. And then basically, this next function pops off the next item. All right, that's all that's going to do here. And so it's not enough to just start the time and run the thing, and then hit the time at the end, because the calling code could be doing other stuff. You could get an item, go do something else for 10 seconds, and then come back and get the next item. And so you actually have to just capture just the time to do iteration. And so basically, and then it just yields those out the same way the underlying iterable would. And then at the end, kind of as a side effect, as it's exiting, calls whatever you've defined as your metric function. And so you can kind of pass different functions in. All right, so that's the basic underlying concept. Make sense? Cool. And so the other iterable versions are just kind of minor variants on these. So the each version, literally it's almost exactly the same. It just calls that metric function for each item as opposed to once at the end. The measure first version should be really, really straightforward. It just calls that for the first one. Now things start to get a little insane. This is some of the gnarliest code I've ever written. So a whole lot of this, basically, there's the decorator stuff has to work in a whole lot of different places. Inside, with name introspection, inside standalone functions, inside classes. We wanted to be able to take var args and handle those correctly as iterables. So there's kind of all these different little variants. And most of this code is just masses of closures to sort of help set up and manage that. Look at this. Look at this. This is creating. People know what if you've never written a decorator before, I'm not going to explain what a closure is, but this is creating classes inside multiple closures, because it actually turns out that's the only way you can do this. And so there's no way I can maintain this without those tests. And so I've showed this to people before, and they're like, "That's hideous," and I kind of agree, but at this point, we're really deep down in the guts of the language. We're really deep down in manipulating how Python itself is implemented. And this is just how you do it. that's just, I mean, there's no cleaner way I can think of to do it, right? I mean, this is just what the idioms look like. You know, I mean, it's just, I mean, this is a descriptor. Like, there's all, like, just tons of metaprogramming magic in here to make this all work and make it so that as a user of this library, you don't have to care about any of this stuff. Right? Like, you know, even the, you know, and then we get down to the block version, which is really nice and plain and simple and straightforward. Cool. Any questions about this part? Stuff. If people want to look at it or like hit me up on IRC or whatever to talk about how actually this works, I'm happy to. I've been programming in Python for about a decade, and I've taken a bunch of Dave Beasley's classes, and it's like without all that, like this is like gnarly stuff. Huh? Yeah, that's what I was going to do. Kernels. All right, so future plans. Basically, more instrumentation. There is... my docs. Yeah. So next version. So this works. This all runs. Next version is basically, I call it instrument all the things. So there's a package, basically Django. Like, can we instrument the Django queries? Can we instrument at the WSGI layer for requests? DBA, smarter, like DBA API handling, like generating metric names by parsing the SQL. Like, you generate the metric name off of the table name or something like that. HTTP clients, things like that. Some more backends. There's a 3.4 has a really nice statistics module that I'd like to swap out for the one I'm currently using, and then kind of better testing. Okay. Questions, feedback? Like, what do people like might want to do with this kind of thing? Like, what sort of backends for output would you want to see? Like, I'm just like, this is kind of still like it's 0.4. It's still kind of like developing, and so part of the reason I wanted to bring it here is not just to show it off because I think it's cool. Maybe. Anybody? Yeah. Oh, sorry. Go ahead. Yeah, that's one of the things I'm hoping to do with the kind of next round of Django integration. There's actually a really nice Django statsd package, which actually has written most of the instrumentation for Django. So to like instrument your database calls, instrument like different parts of your request cycle, but it's specifically tied to statsd, which is fine. But like again, it's only Django and only statsd, and so actually I'm going to rip off a whole lot of that code, and I think would. Oh. Okay. Yeah. Okay. Write that down. I guess, yeah. Yeah. So the question was basically like, you know, the two things you want to optimize for time and space in a program. And so can we instrument for, you know, memory and kind of do that sort of profiling? It actually turns out in Python, measuring memory usage kind of like from within the program is almost impossible. That both has to do with how the interpreter maintains memory and then just sort of what's available. Just a quick note, like, to be clear, like this is not just useful just for the Python code itself, but the external services you're relying on as well. And so that's what those examples using the database in S3 were intended to show. Yeah?
It looks like you're just going off a wall clock from time to time.
Yeah.
And I got a Django app that's 500 threads doing a whole bunch of crap. I'm taking the CPU forever. And I have no idea which thread is going. How much CPU time is this particular thing doing? So I don't know if this is possible. I'm throwing this out.
Yeah, I thought about that. So this is all thread safe in that it'll work correctly, but I can't really think of a way that, so the question was basically, how does this work under threads, right? If you've got a multi-threaded program and you get, you switch threads in the middle of a measurement, like you can't, how do you actually allocate time to particular threads? I'm not sure there's a really good way to do that. I mean, I don't know. I don't know if there's any way you can get a signal when you switch into a new thread. Maybe like I could monkey patch the threading library and try to integrate with what's going on there. And that sounds just I feel like I just want to tell you not to use threads.
Just getting CPU for, say you get a heavy loaded system.
Yeah.
Just getting CPU time versus wall clock time might be a significant gain.
Yeah.
And very straightforward.
Yeah. I'll look into the multi-platform support for such things is kind of a little dicey, but yeah, that's certainly wall clock. Yeah, sure. Yeah, that's a really good question. So the question is, what's the overhead on this compared to something like Hotshot, which is a C profiler? It's relatively small. Again, I originally developed this for use with external services like S3, where like your network time is just going to swamp that. The problem is Hotshot is that it's kind of a really coarse hammer, if memory serves. Like it basically does your whole program and slows down the entire interpret quite a lot. This lets you be a lot more fine-grained. So. Specific function, yeah. Yeah, absolutely. It doesn't do iterators though. Right, that's what this does. Yeah. All right, cool. No, totally. I mean, like, I wish it did, right? Like, I wish I could do this in C, but there's not a way. So, yeah, absolutely. All right, so thank you so much.
Thank you.
Thanks.
Another awesome library.